All right, so 2.3, we are exploring basic exponent rules. So something that you should have learned in Math 1, probably refreshed in Math 2. I have no idea about Math 3. I've never taught it before. And we're going to revisit those exponent rules one more time. So Anna is making brownies and debating between an 8-inch round pan and an 8-inch square pan. If Anna likes thick brownies, which pan should she use? Explain why and use the appropriate calculations to support your answer. So Anna wants thick brownies. So when we pour it in, we are either going to have one pan of thin brownies or thick brownies. So this is really exploring area. So we're going to calculate the area of the round pan and the area of the square pan. Because if she has just this like set amount of batter and she pours it in, if there's a large area, it's going to be a very thin brownie. But if it's a small area, it'll be a very thick brownie. So think of like a baking sheet versus like a cup. If you filled the cup, very small area, you're going to fill the cup up very high. But if it's got a large area, like a baking sheet, it's going to be very thin. You might not even cover the whole thing because there's not enough brownies. So in this case, they're both 8 inches, but one is round and one is square. So for the area of the round pan, I'm going to calculate area, which is pi r squared. So then I plug in the radius, which is going to be 4. If it's 8 inches, that's actually the diameter of the baking pan. So the radius is 4. Calculate, and I get 50.3 square inches. And then for the area of the square pan, it's just the side. It's a square, so it's the side squared. So the area of the square pan is going to be 8 squared, which is 64 square inches. So what does this mean? Well, the round pan is going to have a smaller area. So that means a thicker brownie. And the square pan has a larger area, meaning a thinner brownie. So Anna would probably want to use the round pan for a thicker brownie. Now, if Anna decides that she wants as much crispy edge as possible. So which pan should she use? Explain why and use appropriate calculations to support your answer. So for this one, crispy edges, hopefully you've guessed, is going to be the perimeter. So we'll calculate the perimeter of the round pan and the perimeter of the square pan. Perimeter of a circle is pi times the diameter. And the square pan is just the 4 sides added together. Hopefully that math wasn't anything too difficult for you. So the perimeter of the round pan will be 25 inches. The perimeter of the square pan will be 32 inches. So which one has more crispy edges? Well, the first pan, the round pan, has less side length. And the second one has more side length, which will result in more crispy sides. We have area of your most commonly used geometric shapes here: rectangle, parallelogram, triangle, trapezoid, circle, cylinder, cone, sphere, rectangular prism. Some commonly used formulas: volume, some surface area, and then just area up here. These are the 2-dimensional shapes in the circle, and then these ones are the 3-dimensional shapes. So nothing you need to memorize. I would never expect you to memorize these formulas. You might have, I would hope you know the area of a rectangle and maybe the area of a triangle. But surface area, volume, no way. I do want you to know what the variables represent. Hopefully they're pretty intuitive. You probably should know most of them. A is area, V is volume, S is surface area, capital B is the larger or longer base on the trapezoid. Sometimes you'll actually see B sub 1 plus B sub 2. those are just the two different bases on a trapezoid, because you have the smaller top side length and the longer bottom side length. The book just uses capital B and lowercase b. L is for length, W is for width, B is for base, R is for radius, D is for diameter, and H is for height. Hopefully you knew all of those. If not, there's your notes for them. For this next one, we're going to fill in this table. For each row in the following table, complete the third and fourth column, and then write a conjecture by comparing the second and fourth formulas. So a conjecture is just kind of what rule did you maybe follow, or how did you figure it out? Find a new way to write the expression using exponents that differ from the form given in the second column. First row is completed as an example. So this first one, we'll just walk through it. We have 5 to the third times 5 to the fourth. So notice these exponents are different. What does that third mean? What does that fourth mean? Well, the third means that I'm going to write out the 5 3 times. 5 to the third is 5 times 5 times 5. 5 to the fourth is 5 times 5 times 5 times 5. And then from there, how many 5s do I have? I have 7. So 5 to the 7th power. And then the conjecture is that when you multiply numbers with the same base, keep the base the same and add the exponents. So all I really did to get from the second column to the fourth column was add 3 plus 4, 7. The next one, we have 3 times 5 squared. So what does squared mean? Well, squared means that I write it out twice. So 3 times 5 times 3 times 5. And then from there, what do I do? Remember, I don't really want to, I'm not solving it. I'm not trying to get an answer to it. I'm just trying to rewrite the exponents. So I have 3 squared times 5 squared. Again, I didn't want the answer. Yes, I could have given a numeric answer, but that's not really telling me what rule I used. So the conjecture or the rule, when raising a product, so the 3 times 5 was the product, to a power, which is squared, apply the exponent to each factor. Or I like to say distribute the exponent to each factor, so long as it's being multiplied or divided. I could not do this if we were adding. Since we're multiplying, I can distribute. The next one, pretty similar, except now instead of multiplying, we're dividing, but that squared is still the same. So I'm going to write my fractions out twice, multiplying them together. So 2/3 times 2/3. And then rewrite the result. It's going to be 2 squared divided by 3 squared. So the last one was a product. This one is a quotient, which is division. So when raising a quotient, or the division, to a power, apply, or I like to use the word distribute, the exponent to the numerator and denominator. So we distribute it to the top and we distribute it to the bottom. And then D, we have this 7 cubed squared. So I'm going to first write out 7 times 7 times 7, and then I need to square it. So then I square it. I'm going to rewrite it twice. So I'm going to write the 7 times 7 times 7 twice. So 7 times 7 times 7 times 7 times 7 times 7. I think I said that enough. I don't really know. That was a lot of 7s. And then rewrite. Well, I have 1, 2, 3, 4, 5, 6 of those 7s being multiplied together. So I have 7 to the 6th power. So our rule is when raising a power to a power, we multiply the exponents. So we have 7 cubed squared. So we have 2 exponents. We are going to multiply them together. And then the last one, we have 11 to the 5th power divided by 11 squared. So I'm going to write out 11 5 times on the top and 2 times on the bottom. 5 times, 2 times. And then I don't know like what happened to my sheet here, but for some reason like I cannot get rid of this second one that I have written down, but I just have it there. So I'm going to cancel out the 11. The 11 on the top cancels with an 11 on the bottom. 11 on the top cancels with an 11 on the bottom. What am I left with? I'm left with 11 written out 3 times. So 11 times 11 times 11. So 11 cubed. So the rule here is that when you're dividing numbers with like bases, same base, 11, keep the base, 11, and subtract the exponents. So 5 minus 3, or 5 minus 2 gives us that 3. Okay, hopefully that wasn't too bad. Hopefully you kind of remember some of those exponent rules. I know that I said that this class doesn't really have a lot of straight up math. It's a lot more word problems. There's not too many word problems that I can use these exponents in, so you will unfortunately see just some of this straight up math on your test. I try to keep it to a minimum, but you will see this on your test, so you will need to know some of those rules. Here is just a nice compiled list of the exponent rules. They used variables for the exponents a and b. And then there's some examples that they go through, and they kind of like worked through how they solved it, and then wrote out the steps. So let's go to number 4 and solve some of these. And this one's the last one we're going to do together. There's kind of a lot of them though. Okay. Oh, never mind. I lied. This is the second to last one. We still have to do number 5. Okay. So first one, 17x squared times 2x to the 5th. I'm going to multiply the coefficients, so 17 times 2, and add the exponents. So I get 34x to the 7th. B, I'm going to distribute this 2 to the coefficient and to the exponent because it's really 4 times x to the 4th. So it needs to be distributed. Distributing to the 4 is the most commonly missed thing, I think, in exponent rules. So I need to distribute. It's going to be 4 squared times x to the 4 times 2. So I get 16x to the 8th. Part C, again, I'm going to distribute the 2 both to the coefficient and to the x cubed. So it'll be -5, I put it in parentheses, that's important, -5 squared, and then x to the 3 times 2 power. So I get positive 25 x to the 6th. We did not talk about the 0 exponent rule, but anything raised to the 0 power is 1. And that's the rule. Okay. Now notice that this -8 was in parentheses. Now it's not. So this 0 is only going to the 8. It's not going to the negative. So our answer is actually going to be -1 because it's 8 to the 0 power, which is 1, and then the negative kind of tags along. I actually forgot to do F, so try that one on your own. And then for G, we're adding in some more steps here. We're going to distribute the 2 at the end, the last exponent. We're going to distribute that to the 3, to the x, and to the y squared. I'm not doing anything with the bottom. The bottom just kind of stays the same. So I have 3 squared, which is 9, and then distribute it to the x. X squared, distribute it to the y squared, so y to the 4th. I kept the bottom the same. And now I can cancel, in the green, I can cancel the coefficients. The 9 with a 3 reduces to 3 over 1. And then I have x squared. I can't cancel that with anything, but I have y to the 4th over y to the 3rd. So I can subtract those exponents. If you need like a visual, you'd have 4 y's on the top. Y times y times y times y over 3 y's on the bottom. Y times y times y. and then you could cancel y, and y, and you'd just be left with one y on the top. So our answer is 3x squared y. And then for the last one here, this one's a bit of a doozy. It's got a lot going on. I'm going to distribute the squared on the right-hand side. The first set of parentheses, nothing's really happening to it. It's 8x, y, z. Nothing's changing, stays the same. I'm distributing this squared only to the second set of parentheses. So I distribute and I get 4 squared, which is 16, x squared, which is x to the 4th. I multiplied. Y squared, multiplied again. I got 4. And then z squared. Now I can combine like terms. So I'm going to multiply the 8 and the 16. I'm going to combine the x's, combine the y's, combine the z's. To do that, since the x times x to the 4th, I'm going to add the exponents. So in the end, I have 128, which is 8 times 16. X times x to the 4th is x to the 5th. Y times y to the 4th is y to the 5th. Z times z squared is z cubed. If you're really struggling with these exponent rules, let me know and I can definitely walk you through like a more visual breakdown of why we multiply, why we add in the certain cases. And then the last one, this is an important one to go through. You will see something kind of similar on your test. Here is a little bit of adding in some word problems to it. So we have using geometric formulas with the exponents. So find the area of a triangle whose base is 5 and height is 20. Include the units in your work. So area, if you scroll up, area is 1/2 base times height. I'm going to plug in 5 inches for the base and 20 inches for the height. And it says include the units in your work. So I'm going to keep the units there. Now we have 1/2 times 5 inches times 20 inches. If I multiply 1/2 times 5 times 20, I get 50. Inches times inches, just like x times x would give me x squared. So inches times inches gives me inches squared. So 50 inches squared is my answer. And then part B, we're going to do similar, but we're going to find the volume of a cylinder, which is essentially a 3D type triangle, whose radius is 2 centimeters and the height is 1 centimeter. Find an approximate answer by using 3.14 for pi and round to the nearest tenth. Include the units in your work just like we did. So we scroll up. Volume of a cylinder is pi r squared h. I'll plug in 2 centimeters for the radius, 1 centimeter for the height. Bam, good, brilliant. I'm going to distribute the squared, the 2 centimeters squared. I'm going to distribute that squared. And I will get, in the end, 12 centimeters cubed. How did I do that? Okay, remember pi is 3.14 times 4 times 1. Why was it 4? Because 2 squared is 4. So 3.14 times 4 times 1 gives me approximately 12. And then centimeters squared times centimeters is centimeters cubed. That's why volume is cubed, area is squared. All right, now, last piece. For a sphere, find the ratio of its volume to its surface area. So ratio, typically, I think most people would write a ratio like this. Volume, semicolon? Yeah, I think so. I don't know. The 2 dots. Surface area. You can also write a ratio is a fraction, volume over surface area. And then from there, I'm going to plug in the actual formulas. So volume of a sphere is 4/3 pi r cubed. Surface area of a sphere is 4 pi r squared. Now I'm going to reduce. My pi's cancel out. I have a pi on the top, a pi on the bottom. 3.14 divided by 3.14 is 1. They cancel out. And then I have r cubed over r squared. So I'm going to subtract the exponents, and I'm going to just be left with an r in the top, in the numerator. So then I'm left with, let me rewrite that with everything canceled out. I'm going to have 4/3 r divided by 4. I'm going to rewrite the division so it's not in a fraction. I'm going to rewrite it so it's actually division. 4/3 r divided by 4. Okay, how do I divide? Well, I multiply by a fraction or by the reciprocal. So it's really times 1/4, and I'm left with 1/3 r. Now, this question will appear, not actually this specific question, but something very similar will appear on your test. You will be asked to find the ratio of volume to surface area or area to perimeter. You will have access, of course, to the formulas. You'll just need to know how to find the ratio of each. So look out for that. Okay, and then I believe that is all I have for this section. Go ahead and try the homework problems. Make sure you're showing all of your work.